Hello everyone. In this tutorial, we are discussing about some data visualization technique called pair plots, and we use the dataset as we used previous couple of videos. Same dataset, and here the first line of code shows that sns.pair plot, and this code generates a pair plot using C bounds pair plot function. It takes a data frame containing columns, reviews, size, price, and rating as input, and the pair plot visualizes the pairwise relationships between these numeric variables by creating scatter plots for each possible combinations of variables. The pair plot shows the distribution of each variable, while that off-diagonal elements displays the scatter plots of variable pairs. And these visualizations helps to identify potential correlations or patterns between the selected variables. And the next line of code that crm equal to df1 dot group by, this code groups the data frame df1 by the content rating column, and crm dot mean, the second line of code, after grouping it calculates the mean of the rating column for each group. This result is a series where each group of content rating is associated with its average rating. This analysis helps us to understand the average ratings for different content rating categories in the dataset. And next line of code, crm.mean and .plot.bar. This code plots a bar plot using the result of the previous operation crm.mean and the previous line of code, which contains the average rating for each content rating category. And the x-axis represents the different content rating categories, and the y-axis represents the average rating. Each bar corresponds to a content rating category, with its height indicating the average rating for that category. And this visualization helps to compare the average ratings across different content rating categories. And the next line of code, I mean the crm dot median, this line of code, this code plots a bar plot using the results of the previous operation crm dot median, and crm dot median, which contains the median rating for each content rating category. And similar to the previous plot, the x-axis represents the different content rating categories, and the y-axis represents the median rating. Each bar corresponds to a content rating category, with its height indicating the median rating for that category. And this visualization helps to compare the median rating across different content rating categories. And the next line of code, this sns dot bar plot, the this code utilizes cbounds bar plot function to create a bar plot, and the data parameter here inside this sns dot bar plot, the data parameter specifies the data frame containing the data. X and y parameters determines the variables to be plotted on the x-axis content rating and y-axis rating respectively. And the estimator np.median specifies that the median value of the rating within each content rating category will be used here, will be used to calculate the height of each bar. This visualization represents a comparison of the median ratings across different content rating categories using bars. And the next line of code, this sns.bar plot. This code utilizes cbounds bar plot function to create a bar plot. The data parameter specifies the data frame containing the data, and the x and y parameters determine the variables to be plotted on the x-axis content rating and y-axis rating respectively. Estimator equal to lambda x, and this line of code, basically lambda function we use here. This line of code, np.quantile, this specifies a custom estimator function using lambda. Here it calculates the fifth percentile of the ratings within each content rating category to determine the height of each bar. And this visualization presents the comparison of the fifth percentile rating across different content rating categories using bars. And the next line of code, sns dot bar plot. This code uses Seaborn's bar plot function to create a bar plot. This data parameter specifies the data frame containing the data, as previous line of code we saw. And x and y parameters determine the variables to be plotted on the x-axis and y-axis respectively, and the estimator np.min, I mean the minimum, specifies the minimum value of the ratings, with each content rating category will be used to determine the height of each bar. And this visualization presents a comparison of the minimum ratings across different content rating categories using bars. And After that, this next line of code, sns.boxplot, this code utilizes Seaborn's boxplots function to create a box plot, and the x parameter here inside the sns.boxplot specifies the categorical variable content rating to be displayed on the x-axis, and the y parameter determines the numerical variable rating to be represented by the boxes. And this visualization depicts the distribution of ratings across different content rating categories using boxes, with each box representing the interquartile range and the median of ratings within a category. And sns dot and after that, the next line of code, sns dot box plot, this code utilizes Seaborn's box plot function to create a box plot. The numerical variable rating is passed directly to the function without specifying any categorical variable, and this visualization displays the distribution of ratings using a box plot, showing the interquartile range and median of the entire dataset's ratings. So and oh sorry, and after that, the next line of code, this top four equal to df1 dot geners dot value counts, this line of code counts the occurrences of each gener in the data frame df1, and the result, basically the result is stored in the top four variable, which will contain the counts of each gener. This will helps us to identify the four most popular genres based on the count of apps belonging to each genre. And after that, the next line of code, dictionary of top underscore four creates a dictionary from the first four items of the top four series, where the keys are genres and the values are their respective counts. And the list, we use here the list method to extract the keys from the dictionary and converts them into a list. And the resulting list C contains the names of four most popular genres based on the counts of apps belonging to each genre. And after that, the next line of code, df1 of this line of code filters the data frame df1 to include only rows where the genres column value is present in the list C, which contains the names of the four most popular genres. The resulting data frame df5 contains only the rows corresponding to the four most popular genres. And after that, the sns.boxplot, this code generates a box plot showing the distribution of app ratings across the four most popular genres in the dataset, and each box represents the interquartile range of ratings for a specific genre, with the median rating indicated by the horizontal line inside the box. And after that, the next line of code here, this code creates a new column called size bucket in the data frame df1, and the pd.qcut function is used to basically we use to bin the values in the size column into five buckets based on the quantiles. The parameters used here, the 0, 0.2, 0.4, 0.6, 0.8, and 1 specifies the quantile boundaries, and uh, VL, L, M, H, VH are the labels basically assigned to each bucket. The labels represent very low VL, low L, medium M, high H, and very high VH sizes respectively. And after that, the next line of code, pd dot pivot table, basically this code creates a pivot table using the pd dot pivot table function, and it basically aggregates the data from the data frame df1 based on the specified parameter inside that. So the parameters here, that first is index. This The rows of the pivot table are indexed by the unique values in the content rating column, and columns. The columns of the pivot table are categorized by the unique values in the size bucket column, and the values in the pivot table are populated by the rating column. So the resulting pivot table provided insights into the average rating of apps based on their content rating and size bucket. And after that, the next line of code, pd.pivot table, this code modifies the aggregation function used in the pivot table creation. It calculates the median rating instead of default mean. The parameters, index, columns, and values remain the same as before. The aggregate function parameter is added and set to np.median, indicating that the pivot table should now display the median rating for each combination of content rating and size bucket. And after that, the next line of code, this this code adjusts basically this line of code, this code adjusts the aggregation function used in the pivot table creation to calculate 20th percentile instead of the default mean. The parameters, index, columns, values remain the same as before, and the aggregate function parameter is added and set to a lambda function that calculates basically 20th percentile using np.quantile. This results in the pivot table displaying the 20th percentile rating for each combination of content rating and size bucket. And the after that, the sns dot heat map, this line of code, sns.heatmap. This code generates a heat map visualization using cbound's heatmap function. It basically visualizes the data stored in the pivot table, and a pivot table race created earlier. The heat map represents the relationship between content rating and size bucket, with each cell color indicating the 20th percentile rating for the corresponding combination of content rating and size bucket. And cmap greens sets the color map for the heat map to greens, and not equal to true. This means that displays it basically displays the actual values on the heat map. Overall, this visualization provides a clear representation of how app ratings vary across different content ratings and size buckets. Uh, and after that, the next line of code, this code creates a new column named review buckets in the data frame df1. The values in this column are categorized based on the quantiles of the reviews column using pd.qcut function. And the pd.qcut function, this function divides the reviews column here. This function divides the reviews column into quantiles based on the specific quantile ranges: 20%, 40%, 60%, 80%, and 100%, and assigns the labels as we saw before, VL, L, M, H, VH to each quantile, representing very low, high, medium, high, and very high respectively. So this categorization allows for easier analysis of app reviews based on their volume, providing insights into different review segments. And after that, the next line of code, this code creates a pivot table named race1, that summarizes the minimum rating value across different content ratings and review for volume buckets. So pd.pivot table, this function creates a pivot table data equal to def1. This specifies the data frame for to user use for creating the pivot table. Index equal to content rating, basically sets the content rating column as the index of the pivot table. And columns equal to review underscore buckets, sets the review buckets column as the columns of the pivot table. And values equal to rating specifies that the values of to be aggregated are from the rating column. And aggregate function, this lambda basically lambda x np dot mean of x, which defines the aggregation function to compute the minimum rating within the each group. And this the resulting pivot table race1 shows the minimum rating for each combination of content rating and review volume bucket. And after that, the sns.heatmap, this code generates a heatmap visualization of the pivot table race1 using